Hey math kids, today we're going to talk about domain and range. This is probably a concept you've talked about already in a previous class, but the notation probably was different than how we're going to talk about it today. So the domain, I'm just going to read this straight from the book. So the domain of a relation is a set of values which the variable on the horizontal axis can take. This variable is usually x. So essentially what that means is domain all x values, all possible. Okay, range, all possible y values. Okay, so just remember that, domain x, range y, and you should be pretty good. Now, IB prefers set notation, and so I'm just going to show you a couple examples. So interval notation looks like that. Now in set notation, it's not too bad, but it's all x's such that x is greater than or equal to 3. Okay. Now, if we had something like x is less than 2, it'd be the set containing all x's such that x is less than 2. Okay. Hopefully that's not too bad. Now, if we were like in between two values, something like that, be all values x such that we're in between those two values. And then if we had something like x is less than or equal to 0 or x is greater than 4, be all values x such that x is less than or equal to 0 or x is greater than 4. Okay, and then what if x is just all real numbers? Let's see, something like that. Be all values x such that x is contained on the set of all real numbers. Okay, so those are just some examples. Really, it's just a little bit of extra writing, but conceptually, I think it's about the same. So hopefully it's not too hard for you to adapt to that. Okay, now we are given a graph. Goes through the origin. And it just ends right there. And this is 8, -2. We also know the vertex, or the, kind of like the vertex, this little maxima right there. Okay, so we're asked to find the domain and range of this. There's an arrow on this side. Okay, so the domain, it goes all the way to the left, and then it stops at 8. So we only care about x values. So it's all the way to the left and stops at 8. And so our domain is going to be the set containing all values x such that x is less than or equal to 8. Now it's less than or equal to because this is a filled in dot. And so if there's no values larger than 8 that we have in our domain, and so that's why we write it like this. Okay, now the range, we only care about y values. So we're going to start with something that looks like that. The set containing all values y such that. Now everything needs to be greater than or equal to -2. Because we have this arrow that goes all the way to infinity. And so y is greater than or equal to -2. Once again, it's greater than or equal to because of this filled in dot right here. Okay, let's try another one. So we're given this graph. It's a parabola. We know that the vertex is 2, 1. All right, so the domain, it's going to be x values such that, so set containing x values such that, goes all the way left, all the way right. So we're just going to say x is contained on the set of all real numbers because all x values are valid. Range, y, all values y such that, whoops, this is a negative one. So -1 is the lowest value we can have, and so we're going to say y is greater than or equal to -1, because all these values are okay up here, but nothing down here is okay. Oh, and then close my set bracket. Okay. Now we'll keep going. Now we're going to be given some equations. So we have f of x is equal to the square root of x minus 5. Now, you're supposed to be able to do this one without graphing it, but I think knowing about the graph is very helpful on this one. And so you may just need to memorize like what a square root graph looks like. So square root graph looks like this. This is just y equals the square root of x. Now, -5 is going to shift it to the right 5. So the specific graph of this is going to look like that. So our domain is going to be greater than or equal to 5. And the range, which is y values, it's just going to be from 0 up. So x is greater than or equal to 0. Now another like conceptual thing about square roots, they can never produce a negative number. No matter what we plug in for x, we will never get a negative out here. Now we can get a negative inside of the square root, which gives us complex or imaginary solutions. And that stuff, like whatever we would get, like for example, the domain, if we plug in a number that's not in this domain, like let's say we plug in 0. If we plug in a 0 right there, we get the square root of -5. And that's why it doesn't show up on the graph. That's why it doesn't show up on the domain, is because we get an imaginary number. And we don't want that when we're talking about domain and range. Okay, now let's move on to the next one. So we have f of x equals 1 over x minus 5. Now, when we're talking about the domain, we just want, on this one, we're going to think, what can we not plug in? And so we don't want to create division by 0. And so we would plug in a 5 to create division by 0. So that's what we don't want. So we just say x cannot equal 5. Now, we can do similar thinking if we think of this like a y. And we're going to solve for x to see what we get. So y equals 1 over x minus 5. Now I want x on top, so I'm going to flip both sides of the equation. And then I'm going to add 5. Okay, now what can y not equal is what we're going to ask ourselves. Well, y cannot equal 0. And so we're going to do the same thing. We don't want division by 0. Okay. Also, if you look at the graph, you're going to see asymptotes. So it's going to look something kind of like this. You're going to see asymptotes at these two places. So at x equals 5, 2, 3, 4, 5, we're going to see an asymptote. Then we're also going to see a horizontal asymptote right there. And so it ends up making a graph that kind of looks like this. When we graph this thing. Okay? And that's why the domain and range are what they are. Because we can get infinitely close to 5, but we won't get there. We can get infinitely close to 0, but we're not going to actually get there because of those asymptotes. Okay. Now, let's see. Need more room. Okay, we still have a few more to do. So we have f of x equals 1 over the square root of x minus 5. Yes. Now, this is really just going to combine both of our domain and ranges from the previous one. So if you remember, I'm going to write these answers. So when we had just x minus 5, we had a domain that looked like this. And a range that looked like this. And then when we had 1 over x minus 5, our domain was x does not equal 5, and the range was y does not equal 0. Okay, so because we have 1 over x minus 5 and the square root of x minus 5, like all wrapped up, it's going to combine both of these. So, if we start with the stuff that's written in pink, that's a good starting point. But we can't equal 5 and we can't equal 0. So we're just going to get rid of these equal to signs, and then that's our new domain and range. So the domain for the orange function is going to be very similar to the pink one, but it's just not equal to. And the reason why this works is because it has to have the characteristics of both. It has to have the square root of x minus 5 characteristics, but also the characteristics of 1 over x minus 5. Okay? And so this would be the answer for that orange one. All right, let's keep going. This one says, use technology to help sketch these functions. Locate any turning points, hence state the domain and range. Okay, so okay. Now, unfortunately, you can't use Desmos on like a IB exam. And so I'm going to show you how to do this on TA84. If you have a different calculator, I'm happy to help you figure out how to do it. But this is the one that I have available to me right now. So I'm going to do that. So let's see. Okay, so we go to graph. Okay. Now, we see that it looks like a kind of a wonky parabola. And if you look in your book, you can see a drawing of this as well. Now, what my guess is, if this is like the whole function, which if you look at the book, it really is, then the domain, we already know it's all real numbers. So I'm just going to write that down. So domain is contained on the set of all real numbers. Now the range is going to be, because remember it was kind of like this shape or whatever, so it's going to be from this point down. So y is going to be less than or equal to whatever this y value is right here. And so to do that, what we need to do, we need to go to second calc, and we want to find the maximum. Now it asks for left bound, so you click anywhere to the left of the high point, so you hit enter. Now it asks for a right bound, so you click anywhere to the right, and then it wants you to guess. So try to get the cursor right where you think the highest point is. It's going to think for a minute, and on this problem we only care about the y value, and so negative 5.81. And that's going to be our range. Okay, let's try the next one. This time we're given this function. So we go to our graphing calculator. We get x squared minus 1 over x. Graph it. And okay. So we get kind of a wonky parabola type thing, and then this whoosh. So this is a really strange function. Now the domain is actually pretty easy on this one. Because it's kind of disconnected right here, and it appears that 0 is that place where it is disconnected. That's where our like missing piece of our domain is going to be. And so I think there's a way to actually test that. Is it value? Yeah. So x equals 0. And then hit enter. And see how there's no value. X equals 0, y equals whatever. Doesn't have that. So that's going to be our domain, our missing piece of our domain. So x does not equal 0. Now, if we're looking at this, the range, it goes all the way up here, comes down, goes all the way up. So the positive part is taken care of. This swoops down and takes care of everything. And so our range is actually all real numbers. And that's our domain and range part. Okay, if you need additional help, please come to Math Lab, but until then, calculator.